Hi WebAssembly friends, and thanks for tuning in to this one. This video is all about AI architectures with Spin. We will explore a Spin app that does AI inferencing, and we will start by running the app on our local machine, so both compute and AI inferencing happen on our own infrastructure. From there, we will take the same Spin app and deploy it into Fermyon Cloud so that the app could leverage the beefy GPUs that we provide as part of our managed service offering. But we won't stop there. From there, we will separate compute and AI inferencing. So compute remains on our own infrastructure while we offload AI inferencing to Fermyon Cloud. So that said, let's get started. The architecture of our app is fairly simple. Obviously, we have a Spin app that exposes an HTTP API which users can invoke in order to do AI inferencing. The app itself interacts with the underlying large language model through capabilities provided by language-specific Spin SDKs. In our case, we built the app using Rust, but that's not mandatory. You can choose from a wide range of different programming languages to create Spin apps. All you have to do is check out the templates that the Spin CLI provides. As the outer square already indicates, we will run everything, compute and AI inferencing, on our local machine. Right now, let's move to Visual Studio Code and explore the Spin app. Over here, we will start by looking at the application manifest. And this one is fairly simple. There's only one thing I really want to highlight, which is line 16. Over here, we specify AI models as a property on the component configuration. And this is required because in WebAssembly, every application is executed in a strict sandbox, meaning we have to explicitly provide permissions or specify permissions on the scope of our app in order to make use of resources provided by the outer world. Next, let's dive into the implementation of our Spin app. So as you can see, we use the HTTP router provided by the Spin SDK to lay out the API of our Spin app. The most interesting endpoint is the suggest endpoint, which accepts HTTP post requests. For every request, we deserialize the request payload into a Rust structure that is also responsible for building the prompt, and we will explore that in a second. With the prompt in place, we can do the AI inferencing, and once we get back a result from the large language model, we construct an HTTP response that we can send back to the callee. Let's have a look at the infer request model. So this model provides 3 properties that users can use to customize or to tailor the application behavior. And by looking at the prompt of our app, you can see that this app is all about generating names for babies. At this point, you may ask yourself, but how can I do inferencing on my local machine? And the answer is fairly simple. All you have to do is download the large language models to your machine and make them available to your Spin app. Large language models are big, right? I have downloaded those large language models already to a central location. So they are roughly about 7 gigabytes in size each. If you build and run a Spin app for the very first time, a local .spin folder will be generated. So you can see over here, there's the .spin folder. And what we can do right now is we can create a symlink and link the large language models from the central location into that .spin folder. So we end up with an AI-models folder inside of the .spin folder. Finally, we can run our Spin app using spin up and move over to the second terminal instance to curl the endpoint. Let's invoke the AI inferencing. So this can take a while depending on your actual hardware. Awesome, finally we got back a response from the large language model and our app turned that into an HTTP response. So that's how you can do AI inferencing on your local machine. We just ran a spin app that does AI inferencing on our own metal. Although this is great, the performance wasn't the best, and this is due to limited resources available on my particular machine. We can do better. We can take the same spin app and deploy it into Fermyon Cloud so that our app could use all the resources provided by Fermyon Cloud. All we have to do is to create a free account with Fermyon Cloud in order to deploy spin apps there. Let's move back to the terminal and terminate the spin app. Once you have created your account with Fermyon Cloud, you can do a spin cloud login in order to authenticate your spin CLI with your Fermyon Cloud account. Once that's done, deploying a spin app to Fermyon Cloud is as easy as doing spin deploy. Let's do that. So this one will package the spin app and deploy it to Fermyon Cloud. Once deployment has finished, we can copy the application URL and bring back our curl command over here. Right now, let's replace the origin and let's invoke the request again. Within 3 seconds, we got back 10 names for babies using a royal tone. Awesome. So we deployed the same spin app to Fermyon Cloud and we got a whole different user experience. Instead of an AI inferencing taking 20 to 30 seconds, we are down to 2 to 4 seconds. We won't stop here. Next, we will separate compute and AI inferencing. We will deploy the Cloud GPU proxy to our Fermyon Cloud account. Let's move back to the terminal. And the GPU proxy is provided through a spin plugin. So you can do a spin plugins list to get a list of available plugins. And as you can see, the Cloud GPU plugin is already installed on my machine. If it isn't installed on your machine, all you have to do is to execute a spin plugins install cloud-gpu, which gives you access to the spin cloud GPU init command. And if you execute that one, the Cloud GPU proxy will be deployed to your individual Fermyon Cloud account. Now that deployment has finished, we get back a configuration snippet that we can use to create our own runtime configuration. Let's do that. So let's move over to Visual Studio Code. Let's create a new file and let's call that fc.toml. The name does not matter at all, right? And let's paste in the snippet that we got from deploying the Cloud GPU proxy to Fermyon Cloud. Let's move back to the browser and let's open up the Fermyon Cloud portal. So that's cloud.fermyon.com. And over here you can see Fermyon Cloud GPU has been created 1 minute ago. So you can open the application details and you can copy the application URL from the left hand side. And we place that inside of our runtime configuration file over here. And this is all we need to separate compute and AI inferencing. We tell the spin runtime that we want to leverage a remote HTTP endpoint for AI inferencing. And by using a token for authentication, we can ensure that only our application is able to interact with the Cloud GPU proxy. Let's move back to the terminal. Let's clean the terminal over here. How can we start that? Well, we can do a simple spin up and provide a runtime config file flag, point to our runtime configuration file, which is fc.toml in our case. Let's invoke that one. And as you can see, the app right now runs on localhost port 3000 again. Let's move to the second terminal instance and let's curl the suggest endpoint again. And again, we are hitting localhost 3000. Let's invoke that one. And within 2 seconds, we get back a result. So compute happened locally while AI inferencing happened in Fermyon Cloud. Let's move to the browser for one last time. And as you can see, if we go to metrics, we can see that we have one invocation that went through our Fermyon Cloud GPU proxy. And with that, we made it. We explored 3 different ways how you can run your spin apps that use AI inferencing. We started locally. We ran the app on our own machine, so compute and AI inferencing happened both offline. After that, we deployed the app to Fermyon Cloud, which gave us access to the beefy GPUs, to all the compute capabilities provided from Fermyon Cloud, and allowed us to run the app in a real serverless way. Last but not least, we separated compute and AI inferencing. So compute remained on our own infrastructure. And again, this one, that could be Spin as a runtime. That could be a Kubernetes cluster leveraging SpinCube or Fermyon platform for Kubernetes. However, AI inferencing, that one got offloaded to Fermyon Cloud. And all we did is we deployed a cloud GPU proxy to our individual Fermyon Cloud account and provided a runtime configuration file. That's it. That's how easy it is to run spin apps with generative AI capabilities in different contexts. And now I want to know which one is the most interesting one for you. Are you all in on Fermyon Cloud, or do you prefer a hybrid approach where you can separate compute from AI inferencing? Let's know down below in the comments. And by the way, don't forget to hit that like button and subscribe to our channel. See you next time.